Hello, my name is Oona, and I like to describe myself as a signals and electronics enthusiast. I don't work in this industry, what this con is all about. I've been a programmer for under a year now, but I'm interested in these kind of things, and my blog is all about that. This talk will be a little story about how I found one interesting signal in FM. Now, some of you may have read my blog and may recognize this picture that I made. It is unrelated to this. But I think this is what got me into this con. It was on Hacker News and stuff like that. Okay. So, one night in 2007, I was listening to the radio, a local FM station, and I was watching it on a spectrogram, of course. That's what you always do. And yeah, it looked normal. There's a cutoff frequency at 15.5. But then something weird starts happening around here. There's a sine wave up in the 19 kilohertz area where you cannot hear it. And it's surrounded by two sidebands of I don't know what. So, of course, I had to find out. Okay, this indicates that I will have to play a sound file, which is right here. Of course, I didn't open it beforehand. Let's zoom in a bit. Now, this sound file demonstrates how it sounded like when I mixed down the signal to audible frequencies. It's a radio station playing a familiar song, but it soon transitions into something else. Much better.
Oh yeah, in sweet harmony, let's go
So this is the signal that was up in the inaudible frequency range. Still kind of can't make out what it is by the sound of it, but let's take it to baseband and see what we can find out. There is an audible repetition to it. It sounds like some kind of data, perhaps, just like a modem sound. And yeah, that's where it all started. So what could it be? Well, I know that the only like data transmission that could be in the FM band is RDS. It's called RDS. It just returns to normal. So, RDS is what you see on your car radio when you tune to a station. It instantly knows what the station is. There's a name. There can also be some other text, like the running program and the genre and all kinds of other information. These are some of the acronyms associated with RDS. There's AF, which means alternate frequencies. There is information about like surrounding stations broadcasting the same program in alternate frequencies. So if you drive out of range, actually the radio can automatically tune to one of these alternate frequencies and keep going with the same program. There's CT, which is clock time, so you can synchronize the clock automatically. There is EON, which means extended other networks. It tells the radio what's going on other channels. And for example, if a listener has preferences for genre, he can select another frequency. And there's PI, which is just an identifier for the station, just a numeric identifier. There's PS, program service name, which just shows the name of the station. PTU, program type, radio text, which can include 64 characters of text in pretty much any encoding. And then there is TATP, which is traffic announcement. Now this is interesting because it can actually force the radio to tune to another frequency where there is a traffic announcement being broadcast. And it can also prevent the user from changing frequency if a traffic announcement is going on. And then there is TMC, or traffic messages, which I'm going to talk about a bit later. Also, some pagers use RDS because it's a ready-made infrastructure for pagers, very cheap to transmit all these. Well, the data rate is very low. It's 1.1 kilobits per second. But with some clever use of bits, all this fits in there nicely. Now, the second thing I had to do was read the standard. In the US, it's called RBDS, but it's practically the same. They just have, actually the only difference is that they have a different list of genres of music, for some reason. So yeah, it was 200 pages. It was a bit difficult. I have no background I'm not an engineer. I have no mathematical background. So the error correction codes and all that was a bit difficult, but now I know a lot more about error correction. There were some useful schematics in the standard. For example, there's an example decoder for RDS with all its parts. Well, I had to Google around a bit, but that's okay. And I wrote a Perl script to decode it. And here it is. It shows the PS, program service name, and the radio text, and some other information about what services the broadcast is including. Now, what I was hearing in the audio was a so-called stereo pilot tone, because the FM radio was originally monophonic. There was no stereo, and stereo was added later, and it had to be backward compatible with mono receivers. So they added pilot tone of 19 kilohertz, and when the receiver detects the pilot tone, it can retrieve the stereo data from twice that frequency, 38 kilohertz. And the RDS data is triple the frequency, 57 kilohertz. Now, for some reason, my radio does something weird with the stereo decoding, and some of the RDS data is actually leaking to the stereo decoded signal that I'm hearing. But I didn't bother to filter it out because you can't hear it. But it's there for you to use. It's very silent. It's like minus 50 decibels. But With a good signal, you can decode it. It's not that much above the noise floor, but sometimes it is. Now, it was, of course, a bit, how do you say, it was a hack. Because what I did was, I actually did all of this through a sound card. It was just like through an analog phase. So I had to get a bit deeper. So I found out my radio schematic, and I found out that unlike most radios of today, it's not a one-chip wonder. The RDS decoder is actually in its own chip. And I can get the data out very easily. Now, how do I get this to a computer? I didn't have a Raspberry Pi. It was not popular yet back then. And I experimented a bit with parallel ports, but it proved to be difficult because nowadays nobody has a parallel port, and only USB parallel port like interfaces are for printers, and they actually emulate a printer. And that wouldn't work very well. So how could I get 4 parallel data outputs to my computer? Well, I ended up just getting rid of the quality bit, which tells me if the data is good or not. Well, I can determine that later. I don't need to, well, the ground is just ground, it's not a signal necessarily. Then I'm left with 2 inputs, clock and data. Well, I could reconstruct the clock from the data, but I don't want to. It's too much of work. So what I did was I took a stereo lead, and I soldered 2 leads to the data and clock outputs from the chip, which is underneath an RF shielding here. And I could still use my sound card, but it was much cleaner. It was a square wave all the way out. And I got something which looks like a data. There's a lot of noise, but it's very binary. But then I refined it a little bit, taking all my shorts out from my crappy solder work, and what I got from the sound card looked like something like this. You can see in the red a clock signal, and the green is the data, and it's so very clear. And I was very excited. I had now decoded, or no, actually not decoded, demodulated in a very easy way without using any DSP, these bits. Now, I went on to do some other stuff with it, like I got a Raspberry Pi. I made a little display which shows just, this is the radio, here's the Raspberry Pi with an HD 44780 LCD. I just interfaced with it. It just so happened that the output voltages from the RDS demodulator were exactly compatible with my Raspberry Pi's GPIO inputs, so I could feed the data directly to the Raspberry Pi without any suspicious sound card work in between. Actually, I fried my Raspberry Pi since because the GPIO is not 4 volts, it is 3.3 exactly. Now I know it. But yeah. Okay, but then there was one mystery still remaining, because on one frequency in Finland, there's this TMC, or traffic message channel, which consists of messages for car navigator systems about like recent events, or traffic jams, anything they need to know. They are being constantly updated with this data. And in Finland, it is encrypted for business reasons. And well, that was my next challenge. Actually, I read the standard, and where the crypto is described, it says, the encryption is only light, but it was adjudged to be adequate to deter other than the most determined hacker. Okay, this reads pretty much like a challenge, to me at least. So I went to read the description, and I drew a little crypto diagram. The key space they are using, actually they are only encrypting the location, because they claim that anything else would be too heavy for the channel, too much overhead, and it would get difficult. So, and encrypting the location would be adequate, because that data is useless without the location identifier. Now, the location is 16 bits, and they are encrypting it with a 16-bit key. They have one key per day of month. It changes every night. And this is what they do with it. 3 simple operations: rotate right, shift left, and XOR. Well, this is a proprietary cipher, and that means it is not very secure. I did some post-it cryptanalysis it's so simple that I can actually add the bits on paper and experimented with some locations and things like that. And I went so far as to request the database of all locations from whoever, I can't remember who is the authority responsible for them, but I requested them for scientific purposes because the location is 16 bits. It's actually a reference to a database, so there is no coordinate information or anything like that. So I requested the database, and I started doing some experiments. I figured that all the locations must be nearby the transmitter where they are coming from because the bandwidth is so limited. So I started brute forcing keys, the vast 16-bit key space, and I tested all the possible keys where the messages for today will decrypt to locations near the transmitter. And I got some pretty astonishing results. There were only one key every day that would do this. And I started collecting some data. I noticed that there were these traffic messages, they don't change every day. They could last like a month. There's a roadworks until mid-November, negative direction on this road. It spans 3 location reference points, and there's a speed limit. Okay, well, the same message is, I can read the same message tomorrow, but a different location, which is the encrypted location. And I have the key ID which they send, which is used by receivers to identify the key. Then I just collected them every day for a week or 2, and finally I got them all sorted out. Here they would be, but I redacted the slide to not get myself in any further trouble. Now, again in Perl, I wrote a decoder, and here it is. There's some basic information about the transmission, service provider, location table, which means the database that they are using for locations. It is encrypted. Key identifier is number 5, okay. I have the key. I don't know what the other things means. I just decoded it. Here are some messages in Finnish because the event database that they are using for preset sentences is in Finnish, incidentally. And here I have a location. Oop. Coordinates and everything. Now, I made a blog post because I figured, well, this might be of interest to someone. It's not very strong a cipher, and I hadn't actually found anyone do this before. I had found someone injecting RDS data to car systems to do different kind of funny things, like rerouting their navigators because of imaginary traffic jams or something like that, or jamming their car radio to one frequency. But this is something new. And it got very popular. But the blog post, it was on Hacker News and Reddit forum page and something like that. And I got a takedown request in the comments. Sad request, but can you take this offline? It is kind of our service you hacked. Technology Director of Media Mobile Nordic. Okay, I had kind of promised in the blog post that I will take this down if someone is offended or if any party makes a complaint. Well, I have my definitions for a party and a complaint. So I replied, kind of. Sure, if that's what you deem appropriate. Please send me a cryptographically signed email with a complaint, some explanation as to how I'm infringing your IP rights, and which parts of the post are infringing and should be removed. I will replace them with deleted as requested by Media Mobile Nordic. Also, please provide me with the means of verifying the signature and sender, preferably a public key at the URL under your company domain. Well, I have never heard of Media Mobile Nordic since. Yeah, so that's about it. And about this time, my blog post had been copied all around the world. For example, it is now in crypto, which is kind of, I don't know, I feel honored. Well, that's about all I had to say. Thank you. Any questions? Yes. Microphone. Run, run, run.
Did you consider trying to actually fuzz radios to just emulate the data that you're currently decrypting to actually try to find vulnerabilities in the radio system?
Well, I haven't tried it because I don't have an FM transmitter for that. Well, I didn't have, actually, but it would be an interesting experiment. Because and the navigators are not very expensive. I could buy one of those myself and do some experiments.
Yeah, well, since you said that the text gets rendered by the radio itself, then there's a good chance that it's connected to the whole, how do you call it, canvas system?
Yeah, in some cases it could be.
So,
And
yeah.
it can be used to reroute the navigator's predefined routes or anything like that.
All right. By the way, do you have any code that did you document the thing that decrypts the data, the RDS data? Is it open source?
Well, the code that I use to find the keys is ugly Perl code, and I have it in here, but I don't have it like in GitHub. Actually, the decoder itself is in GitHub, it's a private repo, and I'm still thinking whether I should make it public or not. But all the keys, I don't think I'll ever publish them, but I have some ugly scripts that I use to do it, but...
Okay, yeah, personally, I'm not asking about the keys themselves, but more of the actual structure of the format of the protocol, the way that it actually works.
Yeah, well, the protocol is pretty much defined in the standards. They were actually very fun to read. They were like prosaic.
Thanks.
Interesting stuff.
Any other questions?
Anything else? Yep.
Hi, when you said you can send spurious messages to sat-navs, do you mean to sat-navs which are embedded in the car system?
Also, yes, they are often using RDS TMC for some traffic messages. There could be also like proprietary means for different companies. I don't know, but at least TomToms use RDS TMC often, and Oh, okay, yeah.
Okay, and have you considered looking at the next generation of car computers that send data to insurance companies?
Perhaps. Personally, I don't own a car, so I have no use for this data. But it could be interesting, yeah. Actually, I was listening upstairs the local radio, and there's at least one channel that is broadcasting RDS TMC, but it's not encrypted. It's just in the plane. So I could have demoed it down here, but we are in the basement and the FM spectrum is flat. There's nothing. But there's this, I found the frequency of the stage mics, but there's nothing more.
Any other questions?
You mentioned that you've checked radios in sort of your local area in Finland. Have you looked at other countries like, say, nearby like Sweden or Russia? And if so, have you found any differences between their RDS or equivalent implementations?
Well, I don't travel a lot, so I don't get to listen to other countries like FM band, and I don't have a big enough antenna. I've listened to Estonian radio. They all have RDS, but I still haven't found any TMC signals there.
And have
Maybe
you,
I just need a bigger antenna.
and have you? No?
Yeah, it's
Have you found anything that is non-traffic related on RDS?
Yes, I have actually. I've heard somewhere that at least the Finnish, like the bus stop timetables that are updating automatically with location of nearest buses, they may use the pager feature in RDS, but I am yet to find it in the band. But, well, there is some pager data in Finland in RDS, but there is so little of it, and I can't really get a grasp of it. A burst every now and then, maybe. Anything else? Okay, well, in that case, thank you very much.